Hello all, in this video we will see how to create a UART program on STM32 and how to see the output on the console. So first let us start the STM32 cube IDE. Okay, you must have defined your own directory, right? So we have our own directory and we are just opening up STM32 cube IDE. So again, depending on your system speed, it just opens up. So for us, we already have some code here. For now, let us ignore this because we are starting from the scratch. I'll try to delete itself from the workspace. We are not deleting the contents here on our drive. Okay, so here the first thing you have to do is file new STM32 project. So that's how you have to start your project. Okay, so once you start, it asks set the connection parameters. You can just apply and close. Okay, so as we have told in our previous videos, it might want to download something, but for now you can ignore it because the first step in the creation of new project is STM32 target selector. Okay, so it opens up the target selection window as was explained in the previous video. Okay, so this is how the target selection opens up, and as we did in the previous video, go to the board selector. As we said, always ignore this. Okay, so once the board selector opens up, okay, here as we did previously, Nucleo and F411RE is ours. Click on it, okay, and click next. Okay, so here we want to name it as uart2 underscore STM32. Okay, you can name it as per your convenience. You can name it as code or whatever. Okay, or you can name it as example. So this actually depends on what you want to like, how you want to understand or how you want to read. The naming is very important. Okay, click on finish. There are several rules for naming as well, because we are just talking about a basic project creation. We are not talking about those specific naming conventions here. So it is saying initialize all peripherals with their default mode. You can keep yes. Okay, that is also fine, or you can say no and then initialize as per your requirement as well. Okay, so now the IOC configuration is what we have to do. As we know, this is the .ioc is part of the project, right? The IO configuration. So it takes some time, as we are seeing here. Okay, here what we have to do is, as we already did the basic configuration, we said yes. Okay, so here in the system core, you will have all the GPIO and the system related functionality. You have to go to the connectivity. Okay, in the connectivity, you see here this is USART. Okay, so USART is already selected, and if we go here, you can see that the pins PA2 and PA3, okay, are already selected. So the STM32 F411 has 3 USARTs, and we are using USART2 because USART2 is what is connected to your ST-Link debugger. Like example, if to explain it better, if we open the schematic of STM32 F411 Nucleo Board, you see here this is the main controller, F411 controller, and here there are UART pins, which are PA2 and PA3, as we have talked. Okay, these UART pins are actually going to the onboard ST-Link chip. Okay, so these are going to this particular chip, and this actually helps us output the data on the USB. Okay, you just need to select these pins. If you don't want to select these pins, Okay, you can configure any of the pins as UARTs based on your requirement. I mean other UARTs other than the USART2, and actually have them routed here. And here you need to have again UART2 USB converter or UART to RS232, whatever based on your requirement. You can externally use it, or use another board like Arduino plugged into this, collect the data over the UART from there, and then analyze the data. So that's how you can do. So this is why as we are talking, we have selected PA2. Okay, just to zoom in here for your convenience. So PA2 and PA3 are what are selected here. Okay, now again just highlighting here PA2 and PA3, and then go to the clock configuration. Okay, so for me the system clock 84 looked very high, so let us just try to use the HSI clock, okay, which is the internal RC, and this is actually 16 megahertz. Okay, you can keep the existing one as is, or you can also change as we have changed here. Okay, now let us close it. So it says save. Yes, save the configuration. Do we want to generate the code? Yes, we want to generate the code. This is C++ perspective. Yes. Okay, so the code gets generated. So we have the USART2 example ready. Now what is there as a part of this code? Okay, as a part of this code, you will have the initial configurations. That means whatever the clock configuration we did, and then any other GPIOs which were there part of the default configuration as we have selected yes, and then the user initialization is here. So double click and then right click to go to the open declaration, or you can press F3 as well. So if you go here, this is the initialization. Okay, in the initialization you can see here user2 is the instance, and the baud rate is 115200. So you get to know the baud rate here. You can change here your baud rate, and you can configure it as per your requirement. Now going back to the code again. So as user2 initialization is done, now that's it. So that the basic code or the configuration that we did through IOC only does till initializations. Now what you need to do with the UART, whether you want to output the data or you want to receive the data, whatever need to be done is your application code. So this application code we have to write. Now that is also made very simple with the current AI tools. Okay, now if you have ChatGPT or Copilot, open it, and you can give a prompt STM32 Nucleo Board UART code snippet. Just click on it. Okay, if once you click on it, it just generates a UART configuration code with on the Nucleo board whatever we have given, using the hardware abstraction layer code. Okay, the HCL. So as we have seen here, all this code is part of our initialization. Only what we have to do is we have to have an instance of UART as mentioned here. Okay, try to have the instance. And very important point while you are writing the code after generating from .ioc is, as you can see here, there are few sections like private, micro, private, define. Okay, user code begin includes. So when you are writing code, try to write in the user code, because when you go back to this project and again go to the IOC and configure something, okay, this particular code changes things wherever you have this prototypes. Okay, prototypes or any variables that need to be defined. Now if you see here, already in the code the instance of HUR2 is already created. So if we just go back to the handle, you can see here the UART2 instance is already written, so you need not even write that as well. Okay, so what you need is, you need something where you want to print over serial port. So for this, if you go down, you can see here there is a char message. Okay, you can see you have to write this in the user code begin, such that this doesn't get modified once you have IOC. If you use IOC for recreation, so this is our way to know channel. Okay, so just we are putting that message, and then you have transmit function, and using the hall functions, the delay of 1 second is generated. Again, you see here user code and while user code begin 3. Okay, so let us put it here. Okay, so what we are doing is, we are using the inbuilt functions to transmit. The instance is this, the message is this, and there are other parameters which we can use it as per our requirement. And then there is a delay of 1 second between each message. Now let us try to compile this. Okay, build the project, right? So once you build, you can see there are 0 errors and 0 warnings. So that means what has happened now, we haven't understood at least what is there inside the HAL code. We didn't even look into any function, but without even knowing anything, as a beginner, using the interface .ioc target selection interface that is provided, we configured our code, and then using tools like ChatGPT, we just generated a simple transmit code, copied whatever is relevant, and then pasted it here, and we built it. Now let us try to run this. Okay, so we have built it, and let us run the code. Okay, so here once you launch the project using run, so the name is this, we need a C++ application, the output is .elf, and here what we have to do is we have to select the ST link. Okay, so if you want, you can scan here. So the frequency you can keep auto for now. Okay, and then click OK. Okay, so it actually launches the code, and you can see it launched the code, and it is already downloading and verifying. Okay, so once this is done, what you can do is, okay, so I think it just did not now well, you can go to the serial code. Okay, and just pull out the plug here, the STM board, plug it in case if you want to check. And if you go to the doclight and open it, COM8 is selected here, and click OK. Okay, and baud rate is 115200, and you can see the messages coming. Okay, whatever we have written, very simple, right? For a beginner, you need not even understand how the UART is connected, how the data is connected. Entire hardware is abstracted from you. You just need to know the configuration, use tools like AI, rather than running through the code and configuring yourself. Coding has become very easy, right? You need to use some of the logic things to know where the code need to be included, and it's very simple, right? So this is how the UART communication over STM32 Nucleo Board can be done. Please try from your side, and please let us know if you see any problems.